Hello, boys and girls. Welcome to Mrs. Bandu's Math Movies. This is for Course 2, 4th period, Lesson 2-2, Prime Factorization. In this lesson, we are going to find multiples and factors and also use prime factorization. We do have several definitions that we need to go over, and I'm also going to add a little bit of a note up here, and we'll review this in class as well, but divisibility rules can be found on page 73 in the textbook. I would review those. We will be talking about them in class as well, but it's an opportunity to get a little bit of a head start there. Okay, we have several vocabulary terms, as I said, and our first one is the term multiple. A multiple of a number is the product of that number and any non-zero whole number. Some people also think of this as skip counting by, to get the multiples of 5, you would count by 5, 10, 15, 20, and so on. To get the multiples of 7, you would count by 7s, 7, 14, 21, 28, and so on. Okay. The least common multiple, very commonly referred to as LCM of 2 or more numbers, is the least multiple that is common to or shared by all the numbers. In this case, common to means shared by. Oh, let me make that just a little bit smaller. I'm trying to keep it so you can see, but I want you to be able to see the whole thing. So least common multiple, LCM, of 2 or more numbers is the least multiple that is common to or shared by all the numbers. Okay. A factor is a whole number that divides another whole number with a remainder of 0. Or you could say with no remainder. Okay, so for example, 7 is a factor of 21 because 21 divided by 7 is exactly 3, and there is no remainder, or if you divide out, your remainder would be 0. Okay. A composite number is a whole number that has more than two factors. Okay, so an example of a composite number would be 9, because the factors of 9 are 1, 3, and 9. So it has 1, 2, 3 factors. As long as it has more than 2, then the number qualifies as being composite. A companion to that is a prime number, and a prime number is a whole number with exactly 2 factors. 1 and itself. One is neither prime nor composite. Okay, so that's a good tidbit of information there. If you're trying to determine whether one is prime or composite, the answer to that would be neither, because it doesn't fit prime, because a prime number has exactly two factors. One is its only factor, and for the number 1. And certainly if it doesn't have two factors, it can't have three factors either. So it doesn't qualify as either. Prime factorization is writing a composite number as the product of its prime factors. And for this, we'll use factor trees. So you might want to, again, put a little note in there. So later on when you're reviewing, you can go, oh, how am I supposed to do this? Maybe the word factor trees or the phrase factor trees will be helpful. Finally, the greatest common factor, or GCF, of two or more numbers is the greatest number that is a factor of all the given numbers. Or you can just say all the numbers. We don't have to say given numbers. Okay, so if you're looking at two or more numbers, its greatest common factor is the greatest number that is a factor of all the numbers that you have in the question. Okay. All right then. So you want to review these and be familiar with them. We'll go through them in examples as we go as well. Finding the LCM. This is an application actually of least common multiple. Dan goes to the health club every 4 days. So Dan goes every 4 days. His sister Nisa goes every 6 days. Dan and Nisa both went to the health club today. When will they both go there on the same day again? So again, as I said, this is a least common multiple question, because we're sort of trying to count forward and we want to know when these people would show up at the same place again. So for Dan, we're going to look at multiples of 4. 4, 8, 12, 16, 20, and so on. Okay, we're just going to list the first several. We don't need to list, as a matter of fact, could not list all of them if we had to, because they never end. Okay, Nisa is going every 6 days. So 6, 12, 18, 24, and so on. Okay, the least common multiple of 4 and 6 is 12, because we see that it is the first number that appears both in the set of multiples for Dan and in the one for Nisa. So both will go to the health club again in 12 days. So in 12 days, they will be there together again. Okay, so again, remember what you do is you list out multiples of each number. I would do a few at a time until you can match up a number in each list. The first one that matches up, or the first one that appears in each list, is the least common multiple. There are quick check questions for you to do that. You may pause and do them at this time or come back to them later. I'm going to continue with notes though. Okay. Number 2 is asking us to identify prime and composite numbers. Okay, so if we have determine whether each number is prime or composite. The first number is 17. Its factors are 1 and 17. Because it only has two factors, 1 in itself, 17 is a prime number. The next number is 22, and its factors are 1, 2, 11, and 22. This makes 22 a composite number because it has more than 2 factors. Also, we will be doing a little bit of work in addition to this, looking at primes and composites in class together. So don't freak out too much about it. It's really not that hard, but we will spend some more time on it in class. Number 3, use a factor tree to write the prime factorization of 90. Okay, so many of you have done these before. And basically the first thing we do is the top of our tree is the number that we're going to factor. Write 90 as the product of any of its 2 factors. This particular one is starting with 2 and 45. 2 is circled because 2 is prime. And then we move on and we break down 45 into 5 times 9. 5 is circled, and I continue down to break down 9. 9 is 3 times 3. And then I'm actually going to circle that as well. Okay, so there we wrote 9 as the product of 2 factors. So these numbers that we have circled actually give us our prime factorization. So, and we want to put them generally in order from least to greatest. So I have a 2, and then I have a 3 and a 3. So 2 times 3 times 3, and the 4th factor is 5. Okay, or we have, using exponents, you can write 90 is equal to 2 times 3 to the 2nd power times 5, using our idea of exponents from the previous section. Okay, this is running a little long, so I'm going to go through this last question. When I'm finished, go ahead and complete the quick check questions, and we will come back together in class. Okay, find the greatest common factor of 32 and 48. So we want to write the prime factorizations. The prime factorization of 32 has already been done for us. Let's do the prime factorization of 48 together. 6 times 8 is 48, so I'm going to choose to start with that. Neither of these is prime, so I'm just going to break them down. 3 times 2 gives me 6, and they're both prime. 8 is 2 times 4. 2 is prime. Break down the 4 to 2 times 2. So what I have here are 1, 2, 3, 4 2s. So 2 times 2 times 2 times 2 times 3. I'm not going to write these in exponents this time because I'm going to actually look at some common factors. So now what I do is I match up pairs. Everything that has a partner gets to be circled, but they have to be matching. There's a 2 here. 2 is not the same as 3, so I don't do it. Now for each circle, I write down the factor that is inside each. This is a set of 2s, a second set of 2s, a third set of 2s, and a 4th set of 2s. So 2 times 2 is 4, times 2 is 8, times 2 is 16. I found the product of those common factors. That gives me the greatest common factor of 32 and 48 as 16. Okay, again, we will be doing more of these in class. If you get stuck on this, you should at least be able to do the prime factorizations in number 4 and get that ready to go. All right, I look forward to seeing you in class. Thank you.